In this video, I'll discuss some of the common features, characteristics related to the calendar with Groundhog Day, May Day, Lammas Day, and All Saints Day. So I'll try to answer the question, what do they have in common? Well, some background first. There are 4 special calendar dates related to astronomy and the position of the sun in relationship to the Earth, and especially the tilt of the Earth. That would be December solstice, when at noon the sun is at a low altitude in the sky. The March and September equinox, we have 12 hours of day and night, ignoring twilight. And then the June solstice, when at noon the sun reaches a very high altitude on the sky. This happens because the Earth has a spin axis that's tilted. It's not perpendicular to the plane of the orbit, but it's tilted. In this slide, on the left, we have the time of the June solstice, when the northern hemisphere is tilted towards the sun. We have our warm weather. Probably should also mention, sun is much too big in this diagram. The Earth is much, much too big. But helps us see the continents. We have the equinox positions when the sun is above the equator of the Earth on the sky, and we get the 12 hours of day and night all over the Earth, any location. And then we have the December solstice, when the northern hemisphere is tilted away from the sun and the sun is at a low angle in the sky, and those cause the seasons, this tilt of the Earth's axis. So here are the dates of the equinox and solstice occurring in 2021, and I've done a little counting of those dates, and you can see the times here. It is a little interesting to note that there's more time in the June to September interval compared to the December to March interval. I would point out the Earth's orbit is not a circle around the sun, it's elliptical. And we have aphelion at the greatest distance from the sun. That happens in July. And we have the slowest speed for the motion of a planet when it's at its point far from the sun in its orbit at aphelion. Perihelion, when we're closest to the sun, occurs in January, early in January, and we have the fastest speed here and the shorter amount of time between these solstice and equinox dates. So that's a little bit of a tangent topic. Cross-quarter days. Cultures used to keep track of the halfway time between solstice and equinox, and even would call these the start of a new season. So the cross-quarter days. The quarter days are the equinoxes and solstice. The cross-quarter days are halfway. Shouldn't say roughly, they are halfway between the calendar dates of the solstice and an equinox. And there's a website here that gives some useful information on this. I'll try to put this in the descriptive notes for the video, so you can just click on it and go to the website. So a little more counting. March 20th to June 20th, 92 days, cut that in half. And then on the calendar, I went from March 20th forward. I found May 5th. That would be the cross-quarter time on the calendar. And then from June to September, the cross-quarter date is August 6th. Using the same method, in September to December 21st, November 6th is the cross-quarter date. And then December to March, February 4th is the cross-quarter date. Are these holidays, we'll call them that, Groundhog Day, May Day, Lammas Day, and All Saints Day, are these the cross-quarter days? No, not quite. They're a little bit short, a little bit before, and all 4 of them are a few days before the cross-quarter day. So we have May 1st, and you can see only 42 days from March 20th to May 1st, and then longer time, 50 days to the solstice. And this occurs also for Lammas Day, and then All Saints Day and Groundhog Day as well. These 4 quote-unquote holidays are a little bit short of the cross-quarter date, but cultures would use these dates, the holidays, to sort of celebrate the start of a new season, and that's what we are finding in common between these dates. They're near the halfway point on the calendar between a solstice and an equinox, and these days are near the cross-quarter dates, near enough to be celebrated, not be too far off in terms of temperature of the day you're celebrating, but they do help the cultures to kind of get a little change of mood, get ready for a new season, with Groundhog Day getting us headed towards thinking about spring, May Day getting us thinking about summer, Lammas Day, the harvest coming into play in the fall, and then the All Saints Day headed towards the winter. So that's what we would find in common. A little bit, you might want to do a little more studying on this on your own here about why these holidays are not on the cross-quarter days, but there is some movement on the sky of when the solstice and the equinox occurs in the position, due to the fact that the Earth's spin axis is not stable. It's not random, but it's not always pointed in the same direction. Something called precession causes the North Pole to point at different stars around a circle here, and it takes 26,000 years for the rotation axis of the Earth to complete one circle. Some other websites, I'll put a couple of these also in the description about the changes of the date of solstice or equinox. And I'm planning to create a video on leap day and why we have leap years and how that ties in with calendar and equinox and the solstice date. So if you want to look at some of my other videos, physics and astronomy, these are all free, no registration. I don't use cookies on my websites, and just pick out the ones that you might enjoy. There's a full year of lecture for astronomy, full year of lecture for introductory physics, and lots of physics problems solved, a few astronomy problems solved, but introductory level for both of these courses, suitable for high school or beginning college class in the topic. So hope you enjoy them. Hope you keep watching the sky and learning more about science, astronomy, physics on your own.